Okay, the second method is standard addition methods. This method is used to overcome metric effects. For standard calibration method, it is normally used for lab sample, but standard addition method is used for real sample. What does it mean by real sample? If I can give an example, kalau lab sample ni is I take example of testing a plum boom or lead in the solution. Yeah, real sample is a sample that we get from the environment, for example, from river water, from lake water. Okay, so that is real sample. Lab sample is the one that we prepare in the lab. We buy lab standard from seller, then we mix with the distilled water. That will be a lab sample. So normally real sample will have metric effect. Metric is the interference that contained in the sample other than our analytes. For example, in river water, we might have many other things other than lead in the river water. So those things are called metrics. To overcome metric effect, it is suitable to use standard addition method because we add a real sample into the standard series of solution. So it involves adding one or more increments of a standard solution to sample adequates of the same size. Nanti in the next slide kita akan tengok how to prepare solution for standard addition method in order to plot a calibration curve. And each solution is diluted to a fixed volume before measuring its absorbance. Okay. Okay, this slide will explain step by step of producing standard addition curve, standard addition method, calibration curve. Okay, first, add same quantity of unknown sample or real sample, which is called spike, to a series of volumetric flasks. So we need at least 4. We add same quantity of unknown sample or our real sample. The coarse one is the real sample. You add same quantity. So if let's say you add 5 ml, all flasks must be added with 5 ml of real sample. Then the second step, add gradual amount of standard solution to each volumetric flask. For example, volumetric flask 1, you don't add any standard solution, 0 ml. This one 5, 10, 15. Okay. Standard solution is the stock solution that we know the concentration. The orange one. This one 0, 5, 10, 15. Okay, then the last one, the last step is dilute each flask to calibration mark with distilled water, mix thoroughly and measure the absorbance of each flask. Okay. Okay, once we get the absorbance of the solution from the previous slide, we plot the graph using that absorbance value plus with the concentration of added standard. Okay, this is the plot from the standard addition method. This is the plot for calibration method. Okay, if you can see, these are the difference between calibration method and standard addition method. Calibration method will start from 0, but standard addition method will not start from 0. Even though you don't add the concentration, the standard solution into the flask, the first flask again, you just add the real sample, but there is already have an absorbance, the absorbance from the real sample, because real sample already have the analyte, so that's why it already have the absorbance. It will not start from 0. Jadi dekat sini je, dia dah terus ada dekat sini. So that is another difference between standard addition method dengan standard calibration method. Okay, then you just plotkan graph ni. So dari situ kita just extrapolate either by using graph or by using calculation to get the concentration of unknown solution. Okay, the standard addition method has two ways of preparing solution. Either single point standard addition method or multiple addition method. Kalau single point addition method ni, we just use two flask. Kalau multiple addition method ni, we prepare more than 4 flasks. So we just focus on this. Okay, so we will discuss this on the next slide. Okay, for single addition method, we only use 2 increments of sample, or we just use 2 flasks. Both flasks we add with the real sample or unknown solution. But into one of it, we will not add the standard. Into another flask, we add standard solution. Okay. So the concentration of unknown can be determined using this formula. Vx is the volume of unknown. Okay, kita tahu because concentration volume of unknown are similar for both flasks. A1 and A2 is the absorbance of first flask and the second flask. First flask is the flask with only real sample. The second flask is the flask that contain real sample plus with the standard solution. Okay. Okay, this is an example of a single addition, single point standard addition method. So we have 2 flasks. A 2 ml of urine specimen was treated with reagent to generate a color with phosphate. Following which the sample was diluted to 100 ml. Okay, then to a second flask, they add same real sample, 2 ml juga. Was added exactly. Then 5 ml of phosphate solution. Phosphate solution is a standard solution, was added into the flask, which treated the same ways as the original. Then the absorbance of the first flask was 0.428. The absorbance of the second flask was 0.538. Okay, then calculate the concentration of phosphate in the specimen or in the real sample. Okay. Okay, in this slide, we're going to see how to determine the concentration of urine specimen, or unknown sample. Unknown is the urine specimen. Standard is a phosphate solution. Vx is the volume of unknown or volume of our real sample, which is 2 ml for both flasks. C standard is the concentration of a standard. This one pun kita memang kena tahu 0.0300 milligram per ml. Cx is the concentration of unknown that we are going to determine. Okay. So you just substitute in the value into the equation. Okay, then you will get the concentration of unknown. Okay, so that's all for single point addition method. Okay. So I think we finished with the application of UV spectroscopy. Nanti you all boleh try banyak lagi latihan for this,